Here is a visual example of something that's going to show up on the 1.1 to 1.3 quiz. You're actually going to have a question very similar to this with a picture and a series of 6 questions beneath it asking. So what you're looking at right now, the black are the x and y axis, the purple is the function that will be drawn for you, and then all of the things that are on the right in blue are what you're being asked to find. So what you're looking at here is we have a function that has lots of discontinuities. We have a vertical asymptote. Here this is at x equals -2. We also have a large gap at x equals 0. We have a hole up here at x equals 2. And the rest of the function is nice and smooth. So the first thing that's going to be asked is, where I'm just going to go from top to bottom, the first question at the very top up here says, find the limit as x approaches 2 of the function. So what you want to do is look at x equals 2 right here, and you want to do that finger test where you're going from the left and from the right. And what you'll notice is from both sides, it's going up towards infinity. We talked in class that if something's going up to infinity, we say that it does not exist. That is one of the things that has to be true in order for a limit to exist. It must approach a finite number. This is not a finite number, so we write does not exist or DNE to abbreviate. Next question wants to know what is f of 2. F of 2, same thing, is saying where is at the actual point. So it's not saying what's it approaching, it's saying what's the point. Well, it's going up towards infinity. So in that case, we can say f of 2, we can still say does not exist. We can also write underneath, just to kind of clarify, the reason is because it is going to infinity. There is not a finite number that tells us what it approaches or where it's defined. Next question wants to know the limit as x approaches -5. So here is -5 right here. And we're going to do the finger test or draw the arrows as we approach the left and right. This time our fingers will come together, and your answer is the height that it approaches. It is approaching a height of 0. The next question wants to know f of -5. So it wants to know, is it defined at -5, and if so, where? It is defined. You can see where I put the solid dot. It is defined at a height of 0. So here's a situation where not only does the limit exist at a particular value, but it is also defined at that value. The next problem wants to talk about what's happening to the limit around -2. So here's x equals -2. We are looking at the limit as we approach it from the left and right. So again, using the finger test or drawing the arrows, both arrows are headed to the same height. That is a height of, you might have to count, 1, 2, 3, 4, 5, 6. So my limit is of f of x as we approach -2 is 6, even though it is an open circle, it's not defined there. Next question wants to know what is the function at -2. So here you're looking to see where is it defined, where is the closed circle, and what you'll notice on this graph is there is not a closed circle. If there was a closed circle, for example, down here, you would state that point. If there was a closed circle above or below, you would state that point. We have no closed circle, so this is not defined, does not exist. You could also write undefined. If that circle was filled in, then it would have the same height, kind of like the one up above it with f of -5 had the same value as the limit as x approaches -5. Next question wants to know what's happening at 0. So this is looking at the limit as x approaches 0. So now when we go from the left and right here towards 0 this way, towards 0 this way, this one definitely fails that finger test. The idea that my fingers will not touch if I put my finger on one side and put my finger on the other. So this limit would not exist. One of the other things that breaks a limit from happening is if you are approaching two different values, and that's what this is doing. And then the last one wants to know where is it defined at 0. There is a defined point here. I'm going to color it in really big so hopefully you can see it as you're watching this video. It is defined down there. That is a height of 1. The upper one is open, and you'll never have closed circle on top of closed circle because that would not be a function. So that gives you an idea of what you can see. A lot of times these graphs are very messy, a lot of asymptotes, a lot of gaps, just trying to get you comfortable with the limit, which is what it's approaching, versus the f of that particular number, which is saying where is it actually defined if it's defined.